Hi everyone, welcome back to my channel, and today in this video we are going to design LeetCode. So first of all, before studying the system design, let's jump to the website of LeetCode and see how it looks like. This is what it looks like. So this is the problem page. Here you will see that there are a lot of problems. There are going to be like 2189 array problems, string problems. You can go and solve them. There is one more thing, that is contest. These are the two things that we are going to discuss majorly in our system design of LeetCode. And third point is going to be this authentication, that how we just sign in and sign out. So these are the three things that are going to be our main focus, and majorly we are going to discuss about the problems and the contest, because these two are the main features of our LeetCode website. So first of all, what does LeetCode do? So it helps software engineers, I'm just writing wrong, help software engineers to help solve coding problems. So this is what LeetCode actually do. Now, first of all, let's discuss about the functional requirements of the LeetCode website. So first functional requirement is going to be that we should able to see the problems. Okay, so view problems contain of two things, that we can see the list of problems that we were seeing on this page, the complete problem list. And secondly, when I click on, let's say, to some problem, we should able to see the actual problem also. Oh, my internet is a little slow, but yeah, we should be able to see the problem. Now let's go to the second point, that is going to be submit code, that after seeing the problem we will be able to submit the code. And third is going to be the contest. So if I go to this contests, then with a leaderboard. So whenever we talk about the contest, in the contest, the LeetCode will organize a contest. The users and the software engineers will take a participate in that contest, and after that, whenever you submit a code into that, then there is going to be a leaderboard, and whosoever is going to come first will get the better ranking in that leaderboard. So this is known as the leaderboard, and this is the to some problem. There is going to be some code submission there, that we will going to see it in this second point, submit. Now we are done with our functional requirement, and we can also discuss like authentication system, but we will not go deep dive into this authentication system. But yeah, there is a feature of authentication system. Now let's discuss about the non-functional requirement. So first non-functional requirement is going to be that how many users we are going to support in this website. So let's say we are going to have 50k concurrent users in this website. Secondly, we want to make a leaderboard. So second requirement is that after how much time we are going to update that leaderboard. So there can be a scenario that after submissions, let's say after 10 seconds, the leaderboard will get the latest data. That can be the first scenario. Secondly, we can also make it real time if we do some better engineering. So I'll write both of them. Let's say real time leaderboard. Secondly, let's say we can take like a 5-second delay to update the leaderboard. We'll discuss both the scenarios. Third point is going to be the security of the code execution. So think of it that we are writing the code here, and let's say if I write something that we want, like if I download something, let's say something malicious, so this code is going to be executed somewhere. And if we download something there, it can like destroy the complete machine. That can be an issue. That's why there's going to be some security principles that we have to integrate into that machine, so that we cannot download something from the internet, or there can be some things that we are going to see in the later half of the video, that there should be some security while we are executing the code. Fourth point is going to be the low latency. The website should work fast for viewing the problems. Then there are going to be the code submission as well. So like it should respond in under 30 seconds. Okay, whatever the constraint is, we want to achieve the low latency of the system. After that, there is going to be how many problems that we are going to support. So if I talk about the LeetCode, so LeetCode currently have, let's say, 3.5k problem. It is 3,500 problems right now. But let's say for the max cap, we can say we should support 5k problems. It is not that much number. After that, there's going to be the sixth one. How many submissions people usually do on the LeetCode? So let's say people submit 1 million submissions per day. Or we can say 12 submissions every single second. That is not that much number, because each submission is not coming to one particular problem. That usually happen in the contest. But other than that, let's say the 12 submissions are happening every single second, but on the different problems. Okay, so this is our non-functional requirement. We are done with it. Now we are going to discuss about the APIs in our LeetCode that what are the APIs we should make, and with the help of those APIs we are going to design our entities, or we can say that we are going to do our DB discussion. So first of all, let's discuss about the APIs. First of all, let's make the authentication APIs. There are going to be auth API, let's say, or we can say login API, or I'll just make post. Okay, login, and there is going to be a sign up API. Okay, I'm not going deep into this because this is not the main point. There's going to be a reset password API or something. But yeah, we are not going deep dive into this particular authentication thing. But yeah, these are the 3-4 APIs that are going to be in our authentication system. The user is logged in. Now let's discuss about the other main APIs. First API is going to be that how we are going to see the problems. So that is going to be a get API, in which what is going to happen, that there is going to be a problems, and in the problems we should be able to see the list. And here if you go back to the website, you will see that we have this complete list of the problem, and we have the filters as well. So we have to make these filters also. So that's why I mentioned this question mark, and now we can make the filters. So let's say difficulty. Okay, and let's say there can be company tag as well, company. Okay, and let's say for example offset for pagination, and let's say limit also for pagination. So now we have discussed about the filters, and let's say we can put one more for contest. So let's say this problem is related to some contest, so that's why I put contest as well. Now we have done with the problems. We can make one more API. Let's say now what we'll be making, the submit API. Let's say after clicking on this problem, we'll reach to one problem, or we can make something like that. Then the submit API, then the submit API, and the submit API will say problem ID. For this problem, we are submitting this code. After the submission, we will just going to return the boolean or the error. Okay, so this is the submission API, and after that, let's discuss about the leaderboard. So for the leaderboard, we have this leaderboard API, in which there's going to be a contest ID, for which contest we are showing this leaderboard, and the offset, and offset is going to be this question mark and the limit. So these are the 4 APIs around which we will continue our discussion. First is related to the problems, second is the submit code, and third one is going to be the leaderboard. Now let's discuss about the entities. So first of all, that I noticed that there should be a user table to have our username or something, let's say ID, login, like last logged in, or all these features, so that we can consider that these should be into our user table. There's going to be problems, then after that there should be submissions table, and there is going to be a contest. Okay, and in this contest only we are going to like make our leaderboard. Now let's make some tables. So first of all, let's discuss about the user table. So in the user table, if I talk, so in the user table there should be ID, that should be long, let's say there should be email, that should be string, and let's say there should be one username as well. So username is going to be again string. So these should be the basic fields in our user table. We can of course make more fields, example, like say last logged in time and how many questions that you have solved. We can keep all these things cumulative in the user table to maybe give the better result on the UI. So, but yeah, we will just consider these 3 columns right now. So in the problems, we'll discuss it. So first of all, the ID, that is going to be, let's say, long, because we have just having like 5,000 or let's say 10,000 questions max to max. The title of the problem, third is the title is going to be string, description. Okay, now if I talk about the description, we can keep this description into markdown, because if you'll notice that we have some test cases as well. Let's say for example, if I go there, then you can see that this can be written into the markdown, this constants and every single thing. So this is just a markdown file. So in description, we can just store it into a markdown string. After that, we can take difficulties. What is the tag of this difficulty? So this is going to be an enum. It can be, let's say, medium, easy, hard. After that, we can say at what time we have created this question. Created at. There's one more thing that is the part of the discussion, that is available at. Why I am taking these 2 fields, created at and available at. So created it means that when the actual problem setter of the LeetCode has created this problem. So it means that the problem setter has created this problem and put it into the LeetCode database. But still, it is not available to the user website. So let's say right now we are seeing 3.5k questions on the LeetCode, but it doesn't mean that LeetCode has that much questions. LeetCode has actually going to have, let's say, 5k questions, but 1.5k questions are still not approved. So what is going to happen whenever these questions are, let's say, after like so much testing, when these questions are going to be approved by all the other problem setters and all the other people, then only they are going to put it on that website. So after creation ad, there is going to be some internal steps that LeetCode used to take, and after that only that question is going to come on the actual website. So created it at the time that a question comes to the everyone, to available to the internal LeetCode team, but available, it means that it is now available on the website. So this is the difference, and it's the same logic that we can use it on the contest. For example, when we start a contest, we can say we can put it into the created at. So it means whenever the contest is going on, we can see all the questions in the created at, but users cannot solve it till now. When the contest is over, it is going to add into the problem sheet that we are seeing right now here. So this is the problem sheet. The question is going to add it here, and now people can also solve it. So this is created and available at concept. Now there is one more thing that I noticed was about is premium. So is premium is going to be a boolean field. So this is premium tells us that this question is premium concept. So some of the questions are logged there. So you know that after the premium account, this becomes false or something. So that's why if the user has this premium, so what we can do is we can just mention like say is premium. I'm not sure that LeetCode has the multiple premium accounts. So let's say if user has a premium account, then users can access this premium questions as well. So this is the concept of this premium. And after that, let's say competition. So it means that and competition is going to be an ID. So usually this ID is going to be null if the questions come directly to the problem sheet, or maybe this question will come with the help of the competition. Basically, it comes first into the competition. After the competition ends, it will come to the problem sheet as well. Now, after that, there is company tags. So let's say companies. Now there is going to be hint test cases, and there is going to be all test cases. Okay, now there is a discussion that we can make is that where we should keep these test cases. So it depends. If the test cases are small, they are generally not. So if they are small, we can keep it directly into our database. But if they are actually very big files, for example, we have let's say millions of test cases or something, then we should keep it into the S3 or any bucket. So what we can do is I'll just mention S3 like all test cases link, and hint test cases we can just keep it here like a list, and we can just like store the link here. So or we can just say the string. So these are the problems that we have discussed. So we have discussed the two tables, problems and users. Now let's discuss about the competition table. So in the contest, what is going to happen? There is going to be one ID that is going to connect with this competition ID. I'll just write it here, contest only. So we know that contest we are talking about. And after that, there is going to be the start time of that contest, end time, and there is going to be the problems involved in it. So problems, and the problems is going to be the IDs. Okay, so these are the problems that are going to be the part of the contest, but of course you know that there is not going to be available, it is going to be null right now, and when the contest is going to be over, these problems will actually going to get their available at. So this is the logic. Fifth point is going to be the leaderboard. So there is going to be one user ID, there's going to be the rank, or let's say score, we can just keep it score, and there is going to be question solved or any summary, we can just keep question solved. And if I just copy paste it, so it is going to be a list of data. So this is how our contest will look like. Now in the contest also and in the problem, we are submitting the actual code. So what we are going to do, we are just going to make one last table that is going to be the submissions table that we haven't discussed. So in the submissions table, there is going to be ID. Secondly, if that submission is going to make into the contest, so let's say contest ID, and there's going to be one problem ID, because this too will also make that logic, because contest ID is going to be null, and if there is a contest ID, we know that this submission is made into this contest to this particular problem. After that, there is going to be the user ID, there's going to be the actual solution. Now again, solution can be a text. Now there is going to be errors. Let's say if we got a runtime error or a compile time error, so whenever our compiler will solve the problem, we will return back the error. So we'll store that error into our database. Maybe we can just also store, let's say, runtime error, or like how much time it should taken. We can also keep user test cases. This is very important thing. Remember, whenever we are using Leet, first of all, when you guys write some code on the website, after that you make some custom test cases that we known as the user test cases. Like you close the website and you come back again, you will still find those test cases. Okay, so these are known as the user test case, and then they still exist. There should be something into the submissions that it should be a normal run test case or a final submit test case. So let's say final submission. So final submission means that you actually click on the submit button, or run means that this final submission is false right now. So you are submitting the code with some user test cases, but you are not submitting actually. So this will just run the code and return back some error, but when you submit the code, it will actually test on all the test cases link. This should be the logic. Now we have discussed about the problems, we discussed about the contest and every single thing. Final thing is that which database we should use. That is, the thing is, we don't have so much data right now. We can use MySQL, we can use MongoDB, DynamoDB. It means that we can use SQL or NoSQL, whatever is convenient, we can use that. But right now, if I see my database, what I made is that in this leaderboard, I kept some JSON. There is a list. So what I'm going to do, I will just go with simple DynamoDB, or let's say MongoDB. So I'm basically going with any NoSQL database. Now we are done with requirements, APIs, and our entity discussions. Now let's make our first HLD diagram. That is going to be pretty simple. We are not going to do any deep dive. We are just going to make very simple diagram that will be very easy for you to understand. So what we are going to do is that first of all, we are going to make one client. So in this client, what is going to happen, that this client should have this Monaco editor. Okay, so Monaco editor is provided by the Microsoft, in which what it do is that there is going to be a text editor in which it can do the formatting according to the language. For example, if you choose C, then you can just do the formatting according to the C language or C++. It will solve the syntax error. It can perform some imports. So this is known as the Monaco editor. You can use any other editor. And one more thing, if you simply don't want to use any editor, you can simply choose a .txt file as well. It will also work. But yeah, if you use the editor, then it will be efficient for the users to type. Your website become better. This is why you can use any editor, anything is fine. Now there is going to be one server. On that server, let's say there is going to be one primary server, we can say, and in this primary server, there is going to be, let's say we are going to see the problems. There is going to be like we are going to submit the code. And we already discussed about the database, that there is going to be one database. So, and I will just write it as, that's a database, and this database is going to be, let's say, MongoDB. Now we'll discuss about how we are going to solve this problem with this help of this primary server. So what is going to happen, whenever the user will submit this code, now what is going to happen, the request will run to this primary server, and now primary server will call this, let's say, run code server. Okay, so this is the run code server that will be called. And when this run code server will be called, there are going to be so many virtual machines, or you can say Docker containers. Anything is fine, but we'll go with the Docker containers because it takes less space, more convenient, better. And this Docker containers, what it will do, so we will make multiple Docker containers. So for example, this is a C++ container, this is going to be a Python container. Okay, or this is going to be a JavaScript container, or anything Golang, basically Go container. Now, what is going to happen? Whenever the request will come to the primary server, the request will go to this one of the container will start, and after when the container will start, and then it is going to solve some problem, and it will return that, yeah, problem has been solved, or it can return some error that say, I got a runtime error in this solution. it will return back to the primary server, it will save into the database, it will return back to the client. It is a simple diagram. So let's say we are just using a simple, let's say we can just say that we are simply using the REST APIs here, nothing fancy. Here also this REST APIs. So polling means that whenever client send the request and now client is waiting for the response. So because we are actually running this code onto this particular C++ container, it is going to, let's say, take 30 seconds, and after that it will return back. Now this is a simple diagram, and this is like basically how LeetCode actually works. But now let's make it more efficient and let's discuss the diagram number 2. Instead of running this code on the container, what we can do is we can run this code on the AWS functions, or we can say server REST functions. We can say that we can run this code on Amazon Lambda. Okay. So instead of running this code on this Docker container, self-managed Docker container, we can run it on the Amazon Lambda. So the thing is that we need to understand that, of course, this Amazon Lambda is going to be self-managed. These are serverless functions. They will be more fast, but of course, then there will be cost involved, because there is going to be some amount of money that we have to pay to Amazon to run those functions. Secondly, adding dependencies. Let's say, for example, in Python, there is going to be some question related to NumPy or pandas, then we have to add those dependencies. So every time, whenever the code comes, the Lambda function will start, we will install those dependencies into it, and then it will run it. It will take some time. Same here as well in the container. Whenever the container start, it is going to take some time. So, but it is going to be cost efficient and it is going to be little fast. So this is the major difference between them. And there is going to be one thing that I'll mention in both of them, that there is going to be a cold start. That we have discussed, that whenever the request will come, it will take some time to start. So this is a problem in both of them. Now, before moving to the final design, let's do some deep dives. So we'll solve this cold start problem, how we are going to involve some security rules. We are going to discuss them. I hope you can see it. So first deep dive is going to be the security. That whenever we are going to run a code into our Docker container, it should be secure, that there should be one max runtime involved. For example, that code should not run more than 1 minute. So we can just end up logic. We have to write some custom logic into that container, that code should not take more than 1 minute. Okay. If it is taking more than 1 minute, we are just going to say time limit exceed error, and we will say that it is taking more time. Okay. Same with memory. So we will say max runtime cap should be there. Secondly, security again, that there should be max CPU cap, and there should be again security, max memory cap should be there. Fourth, we can make that again security, that there should be no internet access. And fifth, that after execution of this code, when the code has been executed, we should kill that container. So kill that container. Now, there is one more thing, is about the speed. We want to increase the speed because we have discussed this point of the low latency. But the thing is, in this AWS Lambda and in this Docker, or we can say this worker containers in which we are having this containers running in this particular server, the problem is whenever the API will come, it will execute the container. It means the container will start at that runtime, and it is going to give you the result. But this thing will take some time, because Docker container is also going to take some time to start. So now what we should do, in that thing, we have to make one Docker pool. Okay, Docker pool, and we have to we can say that we are going to make pre-warm pool, and in that pre-warm pool, we are going to just run the code in the container. Okay, I think that you are a little confused what I am saying. So for example, let's say there is going to be a server, and in this server there are going to be a lot of Docker containers idle, in the idle situations right now. Like they exist, but there is no code right now, but they are still running. And whenever the request will come, okay, my code logic will assign one of the container to me, and it will execute it, and it will kill that container. And after that, what will happen? It will again, maybe there is one cron job running at the same time, that is just keep on containing more containers. Okay, and the logic behind of like making the container is going to be, for example, the logic, if I write it down, the logic is going to be something like this. For example, that CPU memory is, let's say, used 80%, less than 80%. Memory is less than 80%. Max we can make, let's say, 20 containers. Running containers is going to be, let's say, 18, because this containers, let's say there are two requests coming, then this container is also going to be used. Okay, and for example, if I enter some language logic, let's say language is going to be C++, should have, let's say, 5 containers, and Java should have, let's say, 4 containers, and Ruby should have, let's say, 1 container. Okay, because like people are solving less Ruby problem, that most of them people are solving the C++ problem. So maybe this is the logic inside a machine. There's going to be cron running that will just figure it out. Let's say whenever the container, let's say whenever the C++ container is going to be 4, then it is going to make one C++ container. Whenever the Ruby container is going to be, let's say, 0, it is going to make one more Ruby container. So this is how one cron is going to make the idle containers. And whenever the request is going to come, it is going to assign one of the container to the code. And now after that, what is going to happen? It will get the code and it will execute it. So now what is going to happen? We don't have to pre-start, like we don't have to start the container at the runtime. Container is already started. So we will just save on that time and we will be able to increase the speed. What else we can do? That there are a lot of requests going on. We have the contests going on, and at the time of contest, there are a lot of requests coming at the same time. So we can use Kafka for scaling. Secondly, I told you that whenever the user will send the request from client to the server, we are using the REST API. And after that, whenever till the time the result is not coming, we are using polling, but that is not the correct solution. We can shift to the WebSockets there, that we will connect with the WebSocket and we will wait for the results. And whenever the result will come, we will return it back. So these are the WebSockets that we can use. So 9th point is logic of parallel execution. Think of it that there is going to be, let's say, 10,000 test cases. So what we can do is we can just run multiple test cases parallel on a single program. So in, let's say, for example, Go, what we can do is we can just run this program. Let's say there can be one main function. After that, that main function calls our function that user has written, and that function can be run on the basis of a Go coroutine. So that multiple test cases can be run at the same time. This is what we can do in logic of parallel execution, so that like we can reduce latency. After that, there is going to be the time penalty logic that we can use in our contest. Assume that the two users solve one question, but there is going to be some time difference in their solving. So what, at the time of measuring the score, we can consider time as a measure. So let's say score is going to be, let's say both the user got the 100 point, and first user solve it at, let's say, for example, 10 0 0 0 1. Then this, what we are going to do, we'll multiply it with something, and let's say we are going to give him, let's say, 102 points, and there is going to be score, let's say, again 100 points for solving the question, but the user solve it at, let's say, 10 0 0 0 2, and we can say he will get the 99 points. Okay, how he's getting the 99 points and how he's getting the 102 point? Because he solved it earlier at 10 0 1 and he solved it at 10 0 2. That's why he get 99 points. How we made this logic? What we can do is that we can take the Unix timestamp, and after that we can multiply it with 100, and we can just figure out one value and we can consider it. This value should not be like 102 or 99. It should not be the case. Any value will be work. Both the values should not match. This is the only thing. We have to make just different timestamps and everything will be fine. Now, after that, finally, we are going to discuss about the high level diagram or a complete diagram of our LeetCode website. Okay, after this LeetCode website, what we're going to do, the request will send to the user. There's going to be a load balancer there. So we'll just put a load balancer. Okay, that will going to distribute the request. So there is going to be one authentication system. There is going to be one problems showing, or you can say the problem server, or there's going to be a submission server. So let me just make first of all the authentication server. So it is like this. and we really want to scale every single thing. So what we'll do, we'll make multiple replicas of this authentication server. I'll just keep it here. Similar way, problem solving server, we'll write it here, problem server. That will show all the problems that we have, that post and the get APIs, these post and the get APIs I'm talking about, this problem server and the other problems related to Sing, and maybe someone wants to add the problem from the LeetCode team, so they can add it into this particular thing. Now there is going to be one submission server. So what we'll do, that the submission server is going to be there, where we are going to submit the code. And now in this problems API is going to be executed, the problems, and here there is going to be one API that is, let's say, login, or we can say sign up, reset password. So these are the APIs in our authentication server. We discussed about the problem server, and this is our submission server. This submission server should be directly connected with our website. So let's me just make a WebSocket as well here. So whenever we submit a code, or whenever user is trying to submit a code, we'll start one WebSocket and we'll wait for the result. We are not doing actual polling now. User submitted the code to the submission server and there is a WebSocket started. And we are now waiting. Basically, the front end is now waiting, the loader is loading, and it is now waiting from the response from the backend. Whenever the user will get any response, it will return true or something. True, or maybe let's say runtime error, anything according to the logic. But yeah, there is a WebSocket involved there. And after that, what is going to happen? We want to scale it. We discussed about in the deep dive that we can use the Kafka producer here, and it is going to put the questions into the queue. This is going to be my queue, and there's going to be one worker pools that are going to actually solve the problem. So basically this whole thing, I'll just copy this box and I'll just paste it down here. So we are going to be this worker. These are going to have the multiple runtimes, okay, that are going to actually solve the problem. So, and there are going to be multiple worker nodes running, which is having multiple containers. So, and these are consuming from the queue, okay, and they have their own custom logic that these are all consuming from the queue, and we are putting all these things into the queue. This is the queue. And after solving, what is going to happen after when they solve the problem, now they are also going to act as a Kafka producer. So now they will produce the logic and our service. So there is going to be one more queue involved, so we will put it back into the queue. So now these worker will put it into this queue, and my service will again act as a consumer. Basically the submission server will act as a consumer, and this consumer, and now they will also consume the Kafka topic. They will consume the solution, and after the solution is consumed, it will return back to the WebSockets. Okay, I'll just again repeat it. Submission server will get the request from the front end, okay, to submit this code. It will push it into the queue, this queue. After that, the worker will solve the problem. After submission is done, okay, maybe you get the true solution, the problem has been solved. It is put that thing into this queue. Queue will consume, and my submission server will consume it, and it will again send it to the user. And whenever all the things will be updated, now we'll connect these two services, because we are just using one single database right now. So what we can do is that we can make one database, or we can just like connect with every single thing here. Okay, so database is not an issue right now here, because the thing is that for this authentication service, like we can make, of course, maintain one, like what I can do is I can just make one more server here, okay, for let's say to keep the, let's say, user table separately. So we can just keep the user logic separately. So let's say user database, and we can keep it MySQL because we don't have that much data. And for this thing, we can just say, let's say, DynamoDB. Okay, so we discussed every single thing, and this is how our diagram is looking at the end. So these are our container pools, these are our queues, Kafka is there, WebSockets are there. The only thing that is left right now is about the leaderboard, that how the leaderboard problem is going to be solved with all these things. So the thing is that leaderboard problem can be solved with the help of Redis now. So here comes the Redis, that what we are going to do, we are going to make one Redis here. Okay, now what this Redis will do, this Redis is again both connecting with this problem server and the submission server. Now let's say whenever we get a solution, what is going to happen, what this Redis server will do, there are 2-3 logics that we can make. So the first logic that we can make is that whenever the user is going to solve, okay, we are going to put it into the database, and after that there is going to be, let's say, we are going to update every single thing into the database, and we are going to make one server side event from database to the Redis, that after every 10 seconds or let's say 5 seconds, run some query, and after that what we can do is we can update leaderboard in Redis. And when the leaderboard is going to be updated, what we can do, we can just simply connect our website with our summation server with the help of this Redis on the basis of the WebSocket. So that after 10 seconds, okay, why with the WebSocket? Because we try to make it a real time. So after 5 seconds, what is going to happen? It is going to be updated, and with the help of the WebSocket, if someone is on the page, it is going to be keep on updated again and again. So this is the one logic that we can make, and we will be able to make it with the help of this server side event that we connected the DynamoDB to the Redis directly. That is the fun thing. Second problem is that it is updating in every 5 seconds. Let's say we want to do it real time. How we can do it? So this can be one more thing that we can do is that we update every single thing into the Redis whenever the context is going on. Think of it as like a celebrity problem. So celebrity problem is like whenever contest is going on, these are the most hot uploads are going to happen. Basically, all the data at the time of contest, there are a lot of people involved. So Redis is very fast. At the time of contest, let's not use database. Let's stick to Redis for the contest. And when the contest is over, with the help of maybe write-ahead logging or with help of the crons, we can put all this data into the database later on. At the time of contest, let's stick to Redis. This can be the first solution. And when we are sticking to the Redis at the time of the contest, then what we can do is in the Redis or in the cache, we'll get the sorted sets. Okay, so I want you guys to study the sorted set. What are these things? Okay, and if you will know them, then there you will see that there are some feature in the sorted set, like say zadd, r range. I'm not sure, r range or something, and there you can like figure it out 0 to 99 ranks. So these sorted set maintain the sorting all the time. So whenever there is going to be change in the score, the data in the Redis is going to be changed, and everything is going to be in Redis. Whenever there is a change in our leaderboard, we can just send the update to the user. That is all going to be real time if we stick to the Redis and we don't use database at the time of the contest. We can just simply update it later on. So this is the final diagram of our LeetCode system. So this is all for the video. I hope you like it, and I hope I'm able to make you understand how the system design of LeetCode looks like. So thanks for watching me, and bye bye, and have a good day.